So in this video, we're going to talk about how to graph a quadratic equation. You've already done some of this, and there are actually many ways to graph any sort of function. So I wanted to highlight just a few tips, but there's no one way to do it. It just kind of depends on what you're given. So here's a few tips. First of all, you can always just use your calculator or Desmos. In your calculator, remember, it's those top buttons. You go to y equals, type in the equation, hit graph, and there it is. Or you can use Desmos, type it into Desmos, and use that as well. Just a reminder, you can also use Desmos on the EOC at the end of the year. You could always do that by hand as well. So you could make a table of values from the equation. So pick some x values, plug them in, see what it spits out. For example, here in this equation, 3x squared minus 5, I picked some x values, put them into the equation, saw what it spits out, and then if you just plot those points on a graph, that's literally what a graph is it's just a visual representation of these coordinates that make this equation true. They're all connected. So that's one way to do it. You could also use what you know about transformations. I don't know if you guys can see this very well. 3x squared minus 5. With transformations, you know things like, is it reflected? Is it dilated? Is it translated? This one, I know it's shifted down 5. That's why its vertex is down here at -5. And I know since this 3 is up front, it's going to vertically stretch it by a factor of 3, which is why it looks very long and tall. You can also use the zeros or solutions. If you know what those are, you know that that's where it hits the x-axis. So you can use that if you have that information. And then you can always find the vertex as well, which we've talked about in past videos. To find the vertex, if it's in vertex form, you just use that, or you could do the -b over 2a thing to find the vertex. So lots of suggestions. Let's go through a few. On this one, notice that it's actually in factored form. It's not in vertex or standard form, it's factored. That's actually pretty handy because that will give me the zeros really quickly, the root solutions. If I just set them equal to 0 and solve for x, this one is 2 and this one's -5. Those are the solutions to this quadratic. Those are what make it 0. Those are literally the zeros where it hits the x-axis at 2 and -5. I also know that the graph opens up because the leading coefficient is positive. So I know my graph looks something, oh that was bad, something like this. That was not super precise. If I wanted to be more precise, I would probably need to find the vertex, or find the y-intercept, or just plug in some x values and see what the y value is. For example, if I wanted to know when x is 1, I could just plug in 1 for x. So 1 minus 2 and 1 plus 5, which is -1 times 6, which is -6. So when I plugged in +1, I got out -6, meaning I should have the point 1, -6 on this graph. So 1, -6, so I was a good ways off. Apparently it goes a little lower. Again, you can use a graphic tool to help you out, a calculator or even Desmos. Here it is on Desmos. You can see I just typed it in here, and here's my graph. It hits at 2 and -5, and it goes all the way down here. If you wanted to be a little more precise and find the vertex, you could. Just depends on how precise you need your graph to be. If I wanted to find the vertex, I could distribute it out. So do x squared plus 5x minus 2x, minus 10, which is x squared. Combine those and get 3x minus 10. And now that it's in standard form, I could find the vertex by doing -b over 2a. So -3 over 2 times 1. which is -3/2. And then you could plug that in for x to get the y value of your vertex as well. I'm not going to do that. I feel like my graph was pretty decent as it was. I didn't really know the vertex, so maybe I should find it to be more precise, but I at least knew the zeros, which gave me a pretty precise graph. Let's try another one. This one is in standard form, so there's a couple things you can do. Again, you could just use Desmos and graph it. That's probably the easiest thing to do if you have it. You could also factor this and see where the zeros are. So what multiplies to give you 8 and adds to give you 6? That would be -4 and -2. So this factors into this. And so then I know my solutions, my zeros, are at +4 and +2. This graph opens up because the a value, the leading coefficient, is positive. So my graph is smiley, so it opens up. On this one, I'm going to be a little more precise. Let's actually find the vertex. So the vertex, the x-coordinate of the vertex is at -b/2a. So -b, so -6 over 2 times 1, which is a. So that's +6 over 2, which is 3. That's the x-coordinate, which we call h. To find the y-coordinate, which we call k, just put 3 into the equation and see what you get out. So 3 squared minus 6 times 3 plus 8. So you can use your calculator if you want. That would be -1. So my vertex is at 3, -1. Which is right here. Okay. So there's a pretty good graph of this equation. Again, you could always put in more things if you wanted to. Like if I wanted to plug in a 1 and see what that is exactly. If I wanted to plug in a 5 and see what it is exactly, I could do that. But this is a pretty precise graph. I know the zeros, I know the vertex, and I know it opens up. Let's try one more. On this one, since the leading coefficient is negative, I know it opens down. In fact, this one is actually easy to graph using what you know about transformations. It starts as x squared, the parent graph that starts at 0, 0 and does the typical parabola. But the negative flips it upside down, and the +2 bumps it up 2. So it would actually look like this. Also, I know that because +2 is the y-intercept, so there we go. This is also kind of in vertex form. The vertex here would be 0 because there's nothing there, and then 2, which is what I have here. Again, you could use Desmos, you could make a table, any of those things, but that's a pretty quick, easy graph to do. So you can use these graphs to identify some important characteristics of the function. We're going to talk about this in the next video.